not the entire story, though. If you look at our function here, it calls a sort method on the array, and sort takes a callback function that presents two elements, and you're supposed to compare them. But since it's an array of anything, we don't really know what the type of x and y are, so we're sort of partially typed here. And you'll note that that we are using a name property off of x here. So maybe what we should do is declare our intent here. We could do that by introducing an interface, and then we could say that A is actually an entity array, like so. Now, what I've done here is I basically said there's such a thing called entities, and entities are objects that have a name property of type string. And then I've said my sort by name takes an entity array. And now we know here we can flow the types. We know that the sort function now is going to present entities to your code. And that in turn means that when we write return x dot, we can give you statement completion on name, and we know the name is a string, so we can show you all the methods. And you see here that we actually here revealed an error also in your program. Someone had mistyped locale compare as local compare, but now that we know the static types, we can correct the code. Just for curiosity's sake here, let's try to introduce a local variable also called name. Now we have two things called name. We have a name property and we have a name local variable. Let's say I go up here and I say I'd like to rename this guy to entity name. You'll see that we can tell these names apart because of static types. We understand that there's a name property and there's a name local variable, and if there were other types with name properties, we would understand that this is not the same type. And so we can safely refactor your code, where otherwise you would have had to go through and look at every occurrence. And of course, in a small program, that's not a big deal, but as a program gets to be 10, 20, 30,000 lines of code, you really don't want to be doing that manually. Okay, in here, we can add additional stuff. Let's say a price colon number. And then let's try to write an entity, var e equals. And then actually, let's say e is an entity equals. And in here now, we can actually suggest for you the available properties. So name, hammer, comma, say price, $5.95. Like so. And it all works out because we have the right types in our program. Let's say now, for example, that I add an extra property in stock colon Boolean here. Now you'll see I get an error message down here that I am missing a property called in stock. But I could make that optional, and now basically what I'm saying in my type declaration is that if there is an in-stock property, then it must be of type Boolean. So if I add that property down here, then if I try to say 10, I get an error now saying that a number is not a Boolean. But if I use the value true, then things are good. Now, one thing that's interesting, too, about this piece of code here is that you'll note that I declared an interface, and then I just used it as an object literal here. Or I created an object literal. I didn't actually have to declare that object literal implements the entity interface. And the reason I don't have to declare this is because TypeScript has a structural type system, as opposed to the nominal type systems that we're familiar with from, say, Java or C#. And in a structural type system, it's really, in a sense, formalized duck typing. You know, an interface declaration just says that an entity is a thing that has a name of type string and a price of type number and an optional property in stock. And anything that fits that is an entity automatically. And you don't have to actually go declare that a class implements this interface or that an object literal is an entity. It just happens if the structure matches. it's a different way of thinking about the problem, but it's actually very, very liberating because it removes a lot of tight coupling between system components. You know, it's always a problem when you're writing a library and someone else is using the library and you have to agree on some types to begin with, but you know, there may not be an opportunity to agree. Where here, as long as you have the right structure, it just works out. Okay, let me try to get rid of that here and this, and then let me try to grab my code and move it with me over to the TypeScript Playground. So I'm going to copy it here and go to the TypeScript Playground, which is off of the TypeScript site, and this is basically a web-hosted little version of the TypeScript compiler. In here, we are hosting the very same compiler that we use in Visual Studio and that we use in a bunch of other places. And the Playground allows you to write code and then see the result in the output pane over here. And in here you see my sort by name. Let's try to add some, let's try to go back and grab some code here for some products, and let's try to paste them in here. Let's give ourselves some products, and now let's try to say var sorted equals sort by name, and you'll see that I actually get statement completion in the browser here, and I can sort by name of products like this. And then let's try to look at what happens when I grab a value out of my sorted. You see that I put in products into my sort by name and stored that in a variable, and now if I grab an element out of there, it only has a name property. But clearly, products here also have price and ID. Indeed, if I hover over products, you see that we have inferred a type here that has a name property and a price and an ID, and it's an array of those. But there's something that's not quite working out here with my sort by name property or sort by name method. Really, what I want to say here isn't that it takes an array of entities. It takes an array of some type that is an entity and returns an array of the same type. Now, how could I say that? Well, one way I could say it is by using generics. So I could add a type parameter t here, whoops, and then I could say that what I'm sorting is a t array, so an array of entities. And now if we go down, if you look at what we've inferred now we've inferred that it takes a t array and returns a t array. And if we go down to the output here, you'll see that the type has flowed through, and now I actually get the right properties on the output. I basically get an array of the same type that I put in. You'll also see a couple of errors here, because we're now saying that there is no name property on t. And that's actually true, because t could be any type, right? So we actually have to write a constraint. So we can say t extends entity. And now that error goes away, and in the call we will check that you're passing something with a name property, but out comes something of the same type. So generics here, now you might go, wow, generics, that sounds crazy in JavaScript. That's got to be really expensive, right? But look at the output code. It's all gone. It's all an illusion, really. These generics don't exist other than at development time. And really, the purpose of generics here is to allow you to accurately model how types flow in your program. They're a conduit for flowing types around in APIs, and that's their usefulness. Okay. Let's try to go back to the IDE here. You might have wondered here, you know, when I say a dot, and we show all of these methods, concat, blah, 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 all of these methods on an array, where does that information come from? Let's try to go back to Visual Studio, and let's actually try to go to the slice method and just say go to definition. So I'm just going to press F12. Now that jumps me into a file here called lib.d.ts, which is the static type information for the entire JavaScript runtime library and the HTML DOM. If you look at how much code there is in here, if we go to the end, it's 14,500 lines of code. And the crazy thing about this is those are the lines of code that you really are supposed to know by heart when you're writing code in JavaScript, right? Because In JavaScript, you just type a dot. I got nothing. Now you need to know that there's a slice method or whatever, because there are no types to guide that process. Here, what you see is that the types, once you write them down, we can serve that information up, and we can actually do all of that grunge reasoning about the types and allow you to do the creative work. I think another thing that's interesting about it is that the types can be provided after the fact. Obviously, the JavaScript runtime library and the DOM weren't written with types in the first place, but we allow you to create these things called declaration files, and they're really, in a sense, like .h files for JavaScript. They allow you to write down all of the static type information, and once we have that, then we can serve it up and check it for you as you're writing your code in the IDE. And indeed, one of the wonderful things that happened after we launched TypeScript was that someone set up a website called Definitely Typed, and they started collecting type declarations for all of the existing JavaScript framework. And that thing has really sort of taken off like wildfire. Let's try to go to the site actually here. It's hosted on GitHub. I think they are up to, I mean, there are 900 contributors up here. People, like, look at how many commits. They have about 800 or 900 JavaScript frameworks covered with type information. And basically, people are using this site to write down the metadata of programming on the web. They're writing down all of the static type information for all of these existing JavaScript frameworks. And now there are tools in place that can automatically provision your projects, a tool called TSD, for example, that goes and grabs definition files from Definitely Typed and puts them in the right place in your directory structure. And so now you can just, in a sense, declare, well, today I'm going to use, say, jQuery with Angular, and I'm going to use some Knockout over here, and it can suck down all the declaration files, and off you are. It's fantastic. And this was all built by the open source community. And it really is a testament to the power of open source. I think it's awesome. Okay, that's a quick overview of TypeScript. Now I'm going to start talking about some of the new stuff that's happening, because a lot has happened in the last year in TypeScript land. In fact, let me try to go to our wiki and show our, oops, that's not ours, that's definitely Types. Let's go to the TypeScript GitHub site. Like I said, we moved here about a year ago, and we've seen an enormous amount of engagement since moving to GitHub. One of the things we keep up to date is a roadmap of all of the releases that we produced, and also all of the work that we are producing in the coming releases. Today, we announced TypeScript 1.5 beta. The final release will be very soon. And in here, you can see all of the features that are in 1.5. 1.5 really has been a very big release in catching up with ECMAScript 6. We sort of went from covering a few features to pretty much covering all but a few features in ECMAScript 6. So destructuring, spread operator, ECMAScript 6 modules, for of, blah, blah, blah. Here you can actually go link to all of the pull requests and issues and get information on how they're implemented and so forth. And I'm going to try to take a look at a few of those. First thing I thought I'd be interesting to look at is ECMAScript